Hello everyone, welcome to another video of Knowledge of Life. In the previous video we have discussed about how does an enzyme work and its various components and what is an enzyme made up of. Now today in this video we will discuss about the enzyme kinetics. So now let's start. Previously we have said that when a substrate or a reactant binds to the active site of an enzyme or a catalyst, then it forms a enzyme substrate complex, and after that there is formation of product and the enzyme gets dissociated from that. So we can say that the number of substrate molecules converted into products per active site of an enzyme in per unit time is known as the turnover number, or it is also known as the Kcat. Now, if we look at a concentration versus time curve of a reaction, then we can see that there is an increase in product concentration and there is a decrease in substrate concentration on the increase in time. So, the rate of formation of product is inversely proportional to the rate of formation of the substrate or the reactant of the specific reaction. So if we derive a rate equation, then we can say that velocity of the reaction is equals to minus ds by dt, where s is the substrate concentration and dt is the change in time, and the negative term is used to denote that there is a decrease in substrate concentration. And we can also say that the velocity of the reaction equals to dp by dt, where P is the product concentration and dt is the change in time. After that, if we look at a velocity versus substrate concentration curve, then we can see that on increase in the substrate concentration there is an increase in rate of the reaction, and after some time when it reaches its maximum velocity there is no more increase in rate of the reaction on increasing the substrate concentration. So we can see clearly that this curve follows two phases, where in the first phase there is an increase in substrate concentration and there is an increase in the reaction rate, and in the second phase there is an increase in substrate concentration but there is no increase in rate of the reaction. So the first phase follows the first order of kinetics, where there is an increase in rate and substrate concentration, and in the second phase it follows the zero order kinetics, where there is no more increase in rate of the reaction on increasing the substrate concentration. Now to explain both of the kinetics, that is the zero order and the first order kinetics of a single enzymatic reaction in a single equation, there is derivation of the Michaelis-Menten equation. And the substrate concentration when half of its Vmax or the maximum velocity is obtained throughout the reaction is known as the Km or the Michaelis constant, and the Kcat versus Km ratio is known as the efficiency of the enzyme or the specificity constant. Now the Kcat versus Km is a very important ratio to define the efficiency of the enzyme, as higher the ratio of the Kcat versus Km, the higher is the efficiency of the enzyme. Now if we look at the equilibrium constant of the reactions, then Kf equals to equilibrium constant of the forward reaction, and Kr equals to the equilibrium constant of the reverse reaction, and Kcat is the equilibrium constant of the product formation. Now according to law of mass action, we can say that Kf equals to E into S, that is the enzyme concentration and the substrate concentration, or we can also say that Kf equals to Kr into Es, that is the enzyme substrate complex concentration. Now from that we can say that Kr by Kf equals to E into S by Es, and the Kr by Kf ratio is also known as Kd, which is known as the dissociation constant. Now according to the pseudo steady state hypothesis, the concentration of Es formation equals to the concentration of Es breakdown, and according to the law of mass action, we know that Es formation equals to Kf into E into S, that is the enzyme concentration and the substrate concentration, and ES breakdown equals to Kr into ES plus Kcat into ES. Now from the pseudo steady state hypothesis, that is the ES formation equals to ES breakdown, we can say that Kf into E into S equals to Kr into ES plus Kcat into ES. Now if we equate them out, then we will find that Kr plus Kcat whole by Kf equals to E into S by Es. Now this Kr plus Kcat whole by Kf is also known as Km, that is the Michaelis constant. So we can say that Km equals to E into S by Es. Now as we have said previously that the rate or the velocity of the reaction equals to the change in product concentration by change in time, that is V0 equals to dP by dt. So we can also say that V0 equals to Kcat into Es. Now during the initial phase of the reaction, some of the enzyme are present freely and some are present in the enzyme substrate complex. Now during the initial phase, the total enzyme present, that is denoted by Et, is equals to E plus Es, that is some are free enzyme and some are in the enzyme substrate complex. Now we can also say that E equals to Et minus Es. Now during the final stage or the Vmax stage, the Et equals to Es, as all of the enzyme gets converted to the enzyme substrate complex and there is no presence of free enzyme, as a result of which the total enzyme present during the Vmax stage is equals to Es. Now from this we can say that Vmax equals to Kcat into Et, or Et equals to Vmax by Kcat. So according to pseudo steady state hypothesis, we know that Km equals to E into S by Es. Now if we substitute the value of E in this equation, that is E equals to Et minus Es, then we will get Km equals to Et minus Es into S by Es. After equating them out, then we will get Km equals to Et into S by Es whole minus S. Now in this case, if we substitute the value of Et, that is Et equals to Vmax by Kcat, then we will get Km equals to Vmax into S by Kcat into Es whole minus S. Now we know that Es equals to V0 by Kcat, or V0 equals to Es into Kcat. Now if we substitute the value of Kcat into Es with V0, then we will get Km equals to Vmax into S by V0 whole minus S. And after arranging all of them, then we will get to the final equation, that is V0 equals to Vmax into S by Km plus S, which is known as the Michaelis-Menten equation. Now in some cases, when the substrate concentration is much more higher than that of the Km of the reaction, then the value of Km can be ignored as the value is very small, and if we put the value of Km equals to 0 in the Michaelis-Menten equation, then we will get V0 equals to Vmax, that is the initial velocity is equal to the maximum velocity of the reaction. Now in some cases, when the initial velocity is equal to half of the Vmax or the maximum velocity, then if we put the value of V0 equals to half of Vmax in the Michaelis-Menten equation, then we will get Km equals to S, that is the definition of the Michaelis constant, that is the Michaelis constant is the substrate concentration when half of its Vmax is obtained. So hope this video will help you, and if you have any kind of query regarding the video, you can put a question in the comment box, and if you like the video, share with your friends and subscribe our channel. Thank you.